Great, thanks. I'm Seth Ladd. I'm a developer advocate with Google Chrome. Advocates work with partners of all different sizes, helping them get up online productively, easily, happily on our products, services, and APIs. Recently, that is all about HTML5. Also the Chrome Web Store, Chromebooks, Chrome OS, Chrome Frame for your legacy browser users out there. And 2012 looks really cool because we recently just announced in Technology Preview our new structured web programming language, Dart. And that's what I'm here to talk to you about today. And because I asked about who here is a Java developer, because that's a little bit about my background and why this project appeals to me so much. C was my first language, but I quickly found Java. Numerous reasons. I think it's a little bit easier to approach thanks to garbage collection. It was kind of built for the internet era, so it had things like URLs. You could fetch network resources, and then it had this crazy thing called applets. And so, anyway, I got into Java programming, and so to me, structured programming was kind of my first exposure, and I was used to a lot of these constructs like classes and interfaces and really functional development environments that allowed me to refactor, rename variables, all this great stuff. And I mean, you read a lot about these techniques, about books, and so that's really cool. And then I was really lucky to get hired here at Google and in the Chrome team, and I had this really funny story. So my background, server-side programming and structured programming, all this great stuff, and they hired me for the Chrome team. I said, wow, that's really cool. I don't really know JavaScript that well. And so I sent an email to this person that my now manager directed me to, and she's like, oh, just talk to this guy. He'll help you feel better about it. And so I sent him this email along, I don't think I'm gonna do good at this job at all. I'm not a JavaScript ninja. I'm always dealing with like Ruby or Java and all this stuff. It's like, don't worry, you'll be fine. Turns out that this guy was my boss's boss, the head of all developer relations. I'm telling the guy I just got hired for, I don't think I'm gonna do very well. So that was kind of funny, but he was cool. So I was kind of thrust into this web programming world, and it turns out that was as exciting or more exciting than the kind of programming I used to do, and I really, really liked it. But I always felt that I was kind of, me personally, missing the kind of structured programming environment that I always felt kind of comfortable in, and I wasn't directly able to bring over a lot of the kind of mental models over to web programming. And certainly that's on me. I should have learned more about kind of the native intrinsic JavaScript-based and CSS-based stuff, and I think I did okay there, still employed. But anyways, when they brought up this project Dart, which one's mine? I was very intrigued, and I said, oh, this speaks right to me. And so that's why I asked about Java developers, because I think Dart is a way to bring a whole new class of developers to the web and have them feel comfortable and familiar and build functional, high fidelity, high performance, high feature web apps for what is arguably the most ubiquitous platform out there. And so that's what Dart's all about. So let me just take these off here. Okay. So Dart, let's get into it. It's a structured web programming language. I like to think of it as batteries included. So it's not just one particular effort. It's a collection of efforts that is really aimed at making the application developer's life a lot more pleasurable on the web. So we're taking a look at a new language, new tools. Tools is the first class system of this effort. New libraries, a new virtual machine. So lots of different elements that all play together under this Dart project. Dart itself is open source. When we announced it in, I think, early October, it was a technology preview, right? Right out of the gate, we said, we have some really good ideas. We're going to put them out there, but we're not done. We're not done by any means. And we wanted to get out kind of the direction we're heading, but with enough lead time that you and the community can help impact that direction of Dart, because it is open source and it is looking to be a major player on the open web platform. And so getting that early feedback, getting the early exposure from communities and users is really important to us. So we launched as open source and technology preview, and it's out on Google Code today. So this talk, it's kind of the high-level whys and whats of Dart. So we have a couple things on the agenda. So really talk about the motivation. I talked a little bit about my particular motivation, what interested me and what got me excited. We'll look at some features of the language that we think are interesting or unique in this setting. We'll talk about its concurrency structure called isolates. We'll look at what we're doing with the DOM, because in the end of the day, it is a web programming language. How do we interact with that browser? We'll look at a couple code samples. We have a couple demos. So current web, right? It's done an amazing job to become the most ubiquitous platform out there, especially for information delivery. And there's a lot of good reasons for this. There's a lot of good parts to the web. Clearly, it's easy to get small to medium-sized apps up on the web. I mean, we're just tremendous amount of interesting and unique and variable apps out there and it's really easy to get started too, right? You can create just a few files, no compilation step, just any web server, host up just a couple files, and boom, you now have a web app. Of course, it's platform independent, right? There's a web browser on nearly everything: set-top boxes, game consoles, every computer, laptop, desktop, notebook, server, even Netflix, right, will port WebKit instead of building custom apps. So I mean, the ubiquity of that web platform, the ubiquity of HTTP and HTML and the DOM, et cetera, that's a good thing. That's something that really excites us, keeps us going, keeps Chrome going. Incremental development, I think, is really key. Let's say you have a 10 gig app and you want to patch one file. You can just upload that single file. So the idea that you can do this kind of incremental uploads, in conjunction with caching at the HTTP level, really does make deployment and distribution much more efficient than if, say, you had to ship a 2 gig zip file, which composed your app every time you wanted to make a tiny little patch. The platform itself, improving very, very, very fast. This is something that we as DevRel really struggle with, because every time we turn around, there's a new API we have to go support. Things like Web Audio API, File System API, WebGL, typed arrays in JavaScript, new ECMA 5 constructs in JavaScript. I mean, you name it. There's a complete resurgence in the web platform, especially for apps. And we see this continue to accelerate, and that's great. The stat that I like to track personally is something kind of near and dear to my heart, and it speaks to the just ubiquity now, the modern web, is that when I last looked, it's greater than 50% of all desktop, laptop, and notebook browsers out there can play Angry Birds. And okay, that's fun, but it actually says that greater than 50% of web users today on desktop, laptop, and notebook can access a modern web app. I mean, this is an app that needs WebGL or Canvas. This is an app that needs hardware acceleration. This is an app that needs fast JavaScript. And this is a really good sign for us application developers, because now that means it's not just like the edges of our users have this great capability. Greater than 50% of how many hundreds and hundreds of millions of users is a lot. And that itself is a platform to be reckoned with. So when we think about developing apps for the web, we like to target modern web browsers as a platform in of itself, a capable, fully functional, fast platform. But we as Google probably know this just as well or as better than anyone else, in that also developing large applications, complex applications, applications that spans multiple team members across possibly multiple locations and time zones. This could be easier. We've taken a couple stabs at it. There's the GWT project, JS compiler, Clojure. I'm sure there's others out there that are all efforts to make programming your modern, feature-rich, large, complex web app easier to manage. And each one of these definitely got us up to this point. We have some really great success stories. I mean, Angry Birds itself is written in GWT. But it's not baked into the actual open web platform itself. It's at multiple levels of abstraction away from running code in the browser. So, we feel that it's hard to find the program structure in these really large apps. We find that the lack of static types, or at least the lack of type annotations, makes it harder for tools to analyze what's going on. And that means it's harder for you to work with the project. We think that tool support could be a lot better, especially me coming from building Java apps, and I'm sure a lot of .NET programmers out there are very thankful for a selection of options here in the IDE level, at the Profine level, at the compiler level. It's just the tooling is a lot more easier to access with more functionality in these other kind of structured programming languages. And believe it or not, even with the improvement in JavaScript performance, in caching performance, in network performance with protocols like Speedy, we feel that startup could be faster. And this is something Chrome takes very near and dear to heart. Speed, simplicity, security. Speed's often the first thing we always say, and what are the 3 tenets of Chrome? So we've done a lot, but we think that there's things we can do better and that we can approach with unique angles here with an effort like Dart to make startup even faster. And the web's been around for a long time. You can't delete stuff from the web. This is, what would it be like if we could take a fresh approach? What would it be like if we can take a new perspective on what it means to have a structured programming environment for the web? And that might be an opportunity to kind of cut out some of the things that didn't actually, some of those dark alleys that are the dead ends of the web platform, and kind of give us a fresh start. So this is what motivated us to take a look at, well, let's give this a shot. We build large, feature-rich apps. Look at Gmails, look at Google Docs. I mean, there's some really great posts out there about what it took to build Google+, and there's a whole lot of Ajax going on there. So what if we actually restarted a new effort, in this case, Dart? We think it fills a vacuum. We think it's a new option, a new approach to building these structured web apps, and that because it's the open web platform, that's capital O, that means we should have a shot at proving its validity. We should have a shot at bringing it to the open web platform because it is open. It is a grassroots effort to make these things bubble up, to try out what works, to put it in front of the community like you guys early on and test it out. We think it's going to be good. So the intro was something about what was the words? Replace JavaScript? Okay, so we actually think it's not aimed at replacing JavaScript, which is it's a subtle but really important point. Dart is aimed at the web app developer, and right now app developers are excited about mobile platforms, and there's some really good reasons for that. But the fact is that the web isn't sexy for app developers. And sure, it's great for pages, great for information delivery, and it's doing a bang-up job there. But we feel that to push the web forward, what we need to do is become more relevant for app developers. So we feel that Dart's not a replacement for anything. It's a new option for building structured, high-performance, high-fidelity, feature-rich apps, but on the web. So in essence, what we're trying to do is say, hey, app developer who might have looked at iOS or Android, why don't you look at the web? Okay, so what is Dart? Dart is, succinctly, a simple, unsurprising, object-oriented language, class-based, single inheritance with interfaces. Okay, so you guys can yawn right now and walk out of the room because, oh, we've seen this all before. But what's kind of cool about Dart is that it also pulls in some unique features, which is really targeted to what is essentially a mass adoption language. And so here you see part of what the thought process behind Dart, which is, yes, it's very familiar. We have classes, we have interfaces, it's single inheritance, stuff we've seen before. But we also have, and we'll talk about these things, optional typing, for instance. We have the concept of isolates for concurrency, real lexical scoping. These are unique elements to the web platform. So we think that we can bring both the kind of structured app developer today through its familiar syntax. And true story, I was sent some code yesterday, and I just started editing it. And I swear I did not know it was Dart code. It was so familiar, I'm like, let me just start adding some methods to this. Oh wait, is this a Dart file? So familiarity, I think we nailed this one. I was very surprised. Okay, so here's the part that people love to debate about. And to me is the most interesting part, and I'm still wrapping my head around it. And it's arguably the most unique feature of Dart, which is again targeted to a mass adoption language. We've seen this before, but has anyone gotten optional typing launched in a mass adoption language? And Dart's given this a shot. So optional typing means just what it sounds, that the type information that you are adding to your classes, interfaces, and functions, actually, it's optional. It does not have to be there. Why are we doing this? Well, we feel that we can decouple the type checking system from the actual language, allowing maybe new efforts to look at what are some new ways to do type checking. It also allows us to appeal to the mass JavaScript developers out there who have never seen a type in their life and probably don't want to come anywhere near a type. But because of the optional typing, as you build larger programs, as you build out your interfaces, your classes start to really architect your system, these types now start to crop in. And this is good for things like tooling. This is good for things like documentation. This is good for things like creating a modular system. So Dart's optional types we feel are kind of an emergence Well, the types themselves will emerge as code grows, as Teams gets larger. And we don't want those types to get in your way. So we think that then optional typing is actually really key, both for adoption, but also really just reducing some of the friction you might experience in the more mainstream structured programming languages where a type system is mandatory. So a good quote here is that the optional typing from Dart is basically innocent until proven guilty. So we're going to let you write that code, and it might actually run even though the types that you specified are, when you look at face value, you say that makes no sense. But actually, the code will still run, and that's important for Dart. So we talked a lot about this, but the optional static typing, you can really think of them as annotations or documentation. So it does not affect the semantics of the running code, but it does help you a ton with your tools. It does help you a ton with interfacing with larger teams and building those larger apps. So if you can just think of it as annotations, maybe even assertions, if you will, if you run in checked mode. But when your running program is running, he's just looking at what you actually wrote. In fact, does this method resolve to this object? Like, if that works, you're good. Even though you might have set a string as a person, that will run in Dart. And so some people will say, like, well, doesn't this allow you to write just horrible code? In which case I would say, you're allowed to write horrible code anyway, regardless if there's an optional type system or not. So you still have to write your unit tests. You still have to kind of validate your code running. But we wanted to remove just another bit of friction from writing, from your experience writing these programs in Dart, so you can get started really quickly. Maybe even write just functions. You don't even need classes. Slowly grow your structure, slowly grow your team members, slowly add types. Boom, now you have a type system that your tools and check mode of Dart can now help you run. So we mentioned that, okay, so the types can also be things like assertions. Well, this is a good way to see it. So you have a type T, a variable X, and a value O. It's kind of like saying assert either X is null or X is T. So when you write these types, that's essentially kind of what you're saying. I have this assertion. I want my tools or my check mode program to check these things for me, kind of like you wrote an assertion. But of course, types are a little bit easier to say that than assertions everywhere. Okay, so moving on to the kind of unique features of Dart. Isolates. You might have seen a slide back there was Dart is single-threaded. Oh my God, everyone has 27 cores. What am I going to do? So the neat thing is isolates are a way for us to get safe concurrency in your programs. So remember though, or remember when I talk about these things, we have kind of two constraints here driving a lot of these design decisions. The first one would be, has to be familiar, right? We're really appealing to the mass audience. So when we look at the code samples, hopefully we'll show you what that means. But our other constraint is, in the end of the day, Dart code has to compile to JavaScript. That's extremely important to be relevant at all on the open web platform. And so JavaScript runs in a single thread on that main page. Excuse me. So we can't add any kind of multi-threading constructs into Dart, won't compile. But we can add something like isolates, which allow you to write isolated code and communicate between that code using the concept of mailboxes or passing messages back and forth. Anyone familiar with Erlang should be familiar with the concept of actors, and you're posting messages into their mailbox and they pop it off on the other end. Those different actors or isolates can run in multiple threads. So isolates let us get concurrency. The other really neat thing about isolates is that as we kind of grow out this ecosystem, and I'm sure as many of us have, we've taken JavaScript snippets from a crazy different amount of APIs and created mashups on our page. But guess what? Each one of those JavaScript guys now is polluting the namespace and communicating as if you wrote every one of those lines. Wouldn't it be neat if you can include JavaScript code into your web page, but run it in an isolated, more safe manner? That's also the theory behind isolates as well. So you should be able to have a page with lots of really great mashup capabilities, but running in isolated functions via these isolates. So not only you get concurrency, but you get safety as well. So isolates will run in the browser and in the server. In the browser, if you're compiling to JavaScript, you can run what are called lightweight or heavyweight isolates. The heavyweight isolates would translate themselves into web workers. If you're not familiar, HTML5 has the concept of a web worker, which allows you to run a snippet of JavaScript code in a separate thread, conceivably running on a different process or thread from the OS, allowing you to get more performance and more safety in that you're passing just opaque messages back and forth. And so a Dart isolate can manifest itself as a web worker if you compile the JavaScript as well. And we mentioned on the server here too, because as we'll see soon, I think the code, nothing about the language design of Dart intrinsically says I can't run on the server. So we completely see the world where you're going to write Dart code and have that same code run on the server via something like node.dart, and on the client via either compiled into JavaScript. So same code running on both ends here, both server and client, to me is also a really big win as well. And we see isolates being a way to get concurrency on the server side. Okay, so we talked a little about these. Okay, moving on. Other really cool, exciting features about Dart bring something unique to the table here. As we all know, as web developers, the base way to interact with the web page is via something called the DOM, the Document Object Model. Now, the DOM was cool because it had a lot of functionality, but it was built in a language agnostic manner. So you look at that API and you say, this doesn't really feel familiar in any language I've worked on. And they did that on purpose to get really good interoperability. But for environments like JavaScript, which has its own unique paradigms and patterns, they built jQuery to make working with the DOM a heck of a lot easier. And working with the DOM via jQuery feels very natural. So of course, when we took a fresh look at programming the web with Dart, we said, well, what can we do here to make this feel natural to the Dart developer and kind of make you feel like you're writing Dart code and not DOM code? And so we built a new library. We call it the HTML library. That it's all in Dart code, feels very natural to Dart, that allows you to interact with your web page in a very Dart-friendly way. And we'll see some samples on this too. But this kind of speaks to, this is our opportunity to introduce new ideas to the platform, introduce new ways of thinking, and possibly not being held back by the corrupt of the past 15 years. Okay, so I've written some Dart code. How do I execute it? What do the different models look like? So certainly you have your Dart source. There's a couple different things that can happen. You can run it directly on a Dart virtual machine. And the Dart VM is part of this open source batteries included project we have today. You can play with it. We also have a couple different tools. We have built out a really great lightweight editor called the Dart editor that you can run code inside and author code as well. We've also built a JavaScript compiler. The most recent compiler is called Frog, because there are Dart frogs out there. And that's designed to give you very optimal, very succinct, terse, but human-readable JavaScript code. So that's one way to get your Dart code to run in the browser. The other thing that we've been working on, and is part of the plan, is support this concept of snapshots. So snapshots allow you to, and this speaks back to that speed, snapshots allow you to take essentially a running Dart program, snapshot that heap, serialize it, send it over the wire, and reinstantiate it over on the other side. So this offers tremendous value to the developer who doesn't want to reparse all that Dart code, who wants to snapshot not just like what you parse and put into memory, but also the state of that running program. You can also think of a model here where you might have a web page that first hits a page with a bunch of Dart code and compiles it all, takes a snapshot, puts the snapshot in its cache. Then the next time you reload, he pulls the snapshot of Dart code from cache instead of reparsing all the Dart code. So it also can help you with that startup, even if you're not just transmitting it from server to client. Now, it's very early days, and so I wanted to pull up this slide to be very transparent with you. We are technology preview, and we're very open. We really love your feedback. Now, this shows that we have a little ways to go. For instance, the Mandelbrot sample demo running in straight up Dart on the Dart VM is 5-point-something times slower now than the equivalent on V8. We know that. Showing you this because we are totally transparent here. But we track these metrics really closely. And so speed is a feature to us. And we will be working to get Dart VM performance up, just like we did with V8, which when it launched just blew everyone out of the water and to this day continues to improve in speed. But the neat thing here is that, as we mentioned, we have a Frog compiler that turns Dart code into JavaScript code, which gets you that ubiquity for your Dart apps. That code is actually pretty good, and we'll continue to make that better. So for instance here, we're running about parallel here with the V8 code of JavaScript from the Dart code compiled to JavaScript here, so 101%. So two different ways to work on it. We're very transparent, working really hard on it. Speed is a feature. So we talked about the snapshot, it's come up a couple times. This stat's really cool. So you can think of something like 54,000 line, which is not even that big, Dart program. Sending that whole unsnapshotted version over the wire, you're going to get something like 640 millisecond startup. snapshot it, send the snapshotted version over the wire, 10x faster startup. This is really important. Anything we can do to make the web faster, and we have many different angles here, from working on the protocols to working on the snapshotting here to working on the rendering engines, et cetera, all to make the web faster. This is an important element. So have we been building Dart in a vacuum? Have we just been like language purists sitting there thinking about what would make the world's best language? No, we've been writing actual real sample apps from the beginning so we can prove out these theories. And they've done a really good job helping us figure out what are the edge cases, how can we improve? And one of our favorite ones is the newsreader here. It's a lot of lines of Dart code. It's actually fully functional HTML5. Let's go ahead and pull it up here. Okay, so if you weren't mistaken, this actually almost might be a native app. So this also just speaks to like the power of CSS3 and the way you can build modern apps with Dart. But as you can see, works really fast. There's a server-side component. This was all Dart code compiled to JavaScript. And you might have remembered this like right when Dart came out that, oh, but if you write a hello world in Dart, you get 7 million lines of JavaScript. Well, let me just show you something. So here's the actual file, and we're going to scroll down a little bit. Oh, okay, those are embedded images. Okay, so here's the JavaScript that's compiled from Dart code. So nice and minified. So we're just going to scroll down a little bit. There we go. Boom. So that's actually not as much as it looked like. And if you saw the other one, it was really huge. So we have an optimized mode for the JavaScript compiler, 1. And 2, we have a new compiler called Frog, which shrinks this even further. In fact, let me, so this is a real life app. Remember, this was what, 1,300 lines of actual UI code. The app itself is 3,000 lines. So that shrank to much, much less than that in JavaScript. So we're working hard to solve that problem. So the Dart editor, again, batteries included is the way we're approaching this Dart project. So the Dart editor is a very lightweight editor, allowing you to get up and running with the Dart project from right when download and hit go. But it's, again, the philosophy behind the Dart project. We want to make web app developers' lives easy, more productive, and part of that is the editors, part of that is the libraries, part of that is the language, part of that is a performant virtual machine. All these things are important for us to address, and the editor is, you'll see it, it's very cool. So I know I've hit on this a couple times, so I want to really reiterate, Dart is not done. We did this early as technology preview to get your feedback, to understand how you want to build web apps. What's been holding you back? What do you need from a new structured modern web programming environment? Please let us know. It's all open source. We have public issue trackers. We have public mailing lists. And we're considering a whole slew of new features like reflection. How is that going to look? I think there's a current proposal in the works now based on mirrors. Enum, should we add that? Maybe. Pattern matching. Here's a good one. If you're from Erlang, you'll remember that you're going to get messages off of your actors, and you want to have a nice way to apply a pattern to the incoming messages so you can route the incoming messages appropriately. Should that be built into the language? How should we integrate with other browsers? So, not done at all. And please let us know what you need to build your modern high-fidelity web app and public. So you can find everything here. dartlang.org is the main website. We have tutorials. We have getting started guides. We have guides for the editor, the language spec itself. And the nice thing about getting in kind of on the ground floor now is the language spec is only around 80 pages, which sounds like a lot, but then you go look at other languages, you're like, I'm never going to read this. So it's actually approachable. So not only is the language familiar, but I think you can actually kind of work yourself through this spec. And some of it's definitely above my head, but it's nice to be able to understand the evolution. It's nice to be able to see within an afternoon what is Dart. So I encourage you to really just check out the website and become part of this project. Dart.google.com is where you're going to find all the code, all the libraries, the virtual machine, the compiler, the sample apps. It's all right there. So I know I've said this a lot. So Dart is a technology preview. We're soliciting input right now every day. We've gotten a lot of good feedback, and we'd like to hear more. Dart is a structured web programming language for the modern web, and we're really building it just to make it easier for people to build modern, high-performance, high-fidelity apps that target the browser. And if we can do that, then I feel like we've done a good job. So please try it and give us some feedback. So we talked a lot about Dart, but what does it look like? And why is this not big? Ta-da! Okay, so this is the most, I mean, there might be more minimal ways, but this is the most minimal thing that I could think of. And what I like about this example here is that some of the early feedback was, this looks too much like Java or something with curly braces. And you can actually write code in Dart that doesn't look like your curly braced based language. You may or may not want to do that, but what's neat here is, again, Dart is appealing to a class of web developers and a class of structured developers. So you should be able to write complete programs based on functions. You should be able to write complete programs without a class. You should be able to write succinct things like this. So here's your main method that prints. And by the way, if you haven't seen the dartboard, this is built in to the website, and you can try it out. You can write your own Dart code. Actually executing the browser, you don't have to download anything to try Dart. This is actually running on App Engine, and if we can get a response, hey, cool. Hello. So it's actually sent it back to App Engine, compiled it to JavaScript, sent that JavaScript back over, and now we're running in the browser. So try out Dart. Hello. Okay, so a little bit more complex now. So we saw the minimalist. Well, what does a class look like? I mean, that's new to Dart, or that's new to the open web platform, right? So here's an example of just a simple point. Shows off a couple things, right? So we have the class syntax here, very familiar. I also like this constructor. Here's a little bit of sugar. If I can highlight this. So if you've been coming from Java, for instance, you've probably done a lot of this.x equals x and this.y equals y. Shouldn't there be an easier way to say that? Here's Dart's sugar for that. If you say this.x and this.y, it will take two incoming method parameters, x and y, and then assign them to the point instances x and y in one line. That's pretty cool. You also see here the optional types. We see var here. And sorry, I got to take this off to see better. Here we go. So I could have used the type here. I didn't have to use a type. Again, appealing to two kind of different classes of developers, allowing you to scale up your code as you go. Here's our main method. We create 2 points and we print. I also like this because we had the string interpolation as well. Just another nice little thing that we added to the language. So if we run this, distance, okay, great. So let's go ahead and do something crazy here. And, whoa. Let's be really wacky. Let's add string here. So that, off the top of your head, says that doesn't really work. But let's run it anyway. Hey. So the program ran. This is what we mean by, one of the things we mean by optional typing, that the types don't affect the semantics of the running code. So yes, this was incorrect. And yes, I should be flogged and had to make a unit test for this. But it's important to point out that this is actually works. But if you say, no, I need those checks, turns out Dart can run in 2 different modes, and you can run in checked mode. And if we turn on check mode, what will happen? Boom. We get our check mode time failure here, where it tells us that, sorry, you can't assign that point to a string. So this is really great. So again, we can't be too upfront with our usage of types. We're going to lose a huge swath of users. So if we can build in a way to kind of scale up to your types and build in a way for you to choose which kind of mode you want to run in, production or checked, we think that we can bring a lot of people to this platform. Okay, let's look at one other example here. This is one of my favorite features. Okay. So it turns out that in Dart, classes have their own interfaces. And here's an example of this. So we have a class duck, you have some method, say quack, he prints quack. Then, as we all are good developers, we have unit tests. And through unit tests, we also create mocks. Because sometimes we, like in this case, we have complex business logic to 3 subsystems, and we don't want to actually integrate that in our unit tests. So we create a mock duck. Now, in maybe more traditional structured languages, you would have had to create an iDuck. But luckily in Dart, that interface is given to you for free. So I have mock duck implements duck. This is awesome. The fact that you won't have to litter your code with iDuck everywhere, to me, is just great, and just is reducing more friction for the application developer. And then in here, I can, oops, sorry, you can't see this. There you go. I can pass in both a mock duck and a duck, and they're both going to work. So neat little feature of Dart. So again, when Dart first came out, the hello world example compiled to a lot of JavaScript code. There's some technical reasons for that. We knew that was less than optimal for the everyday JavaScript developer. And so we started to work on another option. Here's what that option looks like. It's that frog compiler. And thanks to my buddy Bob here, he put up this really cool example here of, here's the Dart code. Okay, we have a simple class. And this isn't even the most succinct way to write this, but just shows you like, I'm going to create a class. It's going to have a static method, and I'm going to call it from main. Okay, let's turn that into JavaScript and run that on modern browsers. Well, it turns out that here's the JavaScript code. Hopefully you guys can see this. Let me just increase this a little bit. Here's the JavaScript code that Frog will spit out. This is fairly human readable. It's very terse, has these nice comments. And so that using the Frog compiler today, which is open source and in our source repo, you could take your Dart code, compile the JavaScript, be actually to understand that JavaScript, and then you can run this through your own minifier and get even smaller. So I think we've answered those initial concerns. So we're feeling pretty good. But again, none of this is done, so we have more to do. Cool. Well, thanks everyone for your time. This has been awesome. Darling.org, check us out. Thanks.